press the bell icon on the YouTube app and never miss another update.
Hello students, we discuss the next topic in three-dimensional geometry. The next topic is distance between 2 points in space. You already know in the 10th class, distance between 2 points in plane, correct na? Distance between 2 points in plane, the formula is, suppose A and B are the 2 points in plane, AB is equal to x2 minus x1 whole square plus y2 minus y1 whole square. Correct? You already know in 10th class, distance between 2 points in a plane is given by A and B are 2 points lying on the plane. AB is x2 minus x1 whole square plus y2 minus y1 whole square. So now we derive the formula distance between 2 points in space. Okay, so very important derivation. So here this derivation asked in the examination for 5 marks. So for that we draw a space, rectangular coordinate space. So for that I draw 3 axes, x axis, y axis and z axis. These 3 axes, they are mutually perpendicular to each other. Let P be a point in space. P be a point in space. One more, Q be a point in space. Okay, these P and Q are, P be a point in space means ordered triplet, x1, y1, z1. Q be a point in space means it contains a coordinate, x coordinate, that is x2, y2, z2. x2, y2, z2. So I written here, let P of x1, y1, z1 and Q of x2, y2, z2 be 2 points in space. Correct na? I draw here. Be 2 points in space. P and Q be 2 points in space. Next what I do here, draw PM because I want to represent the coordinate. Draw PM perpendicular to XY plane and draw QN. Draw QN perpendicular to XY plane. Next what I do? Draw PM and QN perpendicular to XY plane. Draw PM, QN perpendicular to what? XY plane. So join PQ. MN. Join PQ and MN. Observe the coordinates of M and N in XY plane. Last session I discussed the coordinates in XY plane, the Z coordinate is 0. That means the coordinate of M is x1, y1, 0. x1, y1, z coordinate is 0. The coordinate of n is x2, y2. Correct? x2, y2. I written here. Since m and n lies in xy plane, that implies the coordinate of m is x1, y1. And the coordinate of n is x2, y2. x2, y2. The distance between m and n, you already know this one. That's why I discussed. Distance between m and n x2 minus x1 whole square, correct, plus y2 minus y1 whole square. Distance between m and n, x2 minus x1 whole square plus y2 minus y1 whole square. Next what I do, draw PR. Draw PR perpendicular to QN. Draw, once again, draw PR perpendicular to what? QN. Observe carefully. MN, the distance between M and N, correct, is same as the distance between PR. Correct? By figure we observe that Mn is nothing but PR. Mn is nothing but PR. What about Mn? Mn is nothing. Mn is square root of x2 minus x1 whole square plus y2 minus y1 whole square. That implies PR is square root of what? x2 minus x1 whole square plus y2 minus y1 whole square. PR is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay. From figure, PQR is a right angled triangle. Yes. P triangle PQR is a right angled triangle. Correct na? PQR is a right angle triangle. Why? Since angle R is equal to 90 degree. Using Pythagoras, PQ square is equal to PR square plus QR square. Correct? PQ square is equal to what? PR square plus QR square. So already we know that distance between P to R. Distance between P to R is nothing but what? x2 minus x1 whole square plus y2 minus y1 whole square. That PR is no. So we find QR. Observe here. QR. This distance I want. Correct? Carefully observe the figure. QR, this distance I want. From figure, QR I written as, okay, QR I written as QN, Q2N minus RN. Is it correct? So I want QR. So for that QN minus RN, Q to N minus R to N is nothing but what? Is nothing but QR. So QN, so you know already last class I discussion, QN, the coordinate of Z axis, that is nothing but Z2. QN is nothing but the coordinate of Z axis, that is nothing but Z2. Fine. Minus. Observe carefully. RN. Okay na? RN is same as PN. Observe the diagram carefully. The distance from R to N, is same as the distance from P to N. Rn is same as P to M. Since Rn is equal to what? PM. Why I written PM? PM is nothing but coordinate of Z1. Correct? So that is nothing but Z2 minus Zn. So QR is equal to QR is equal to what? Z2 minus Z1. Substitute here. QR is equal to what? Z2 minus Z1. PR is equal to X2 minus X1 whole square plus Y2 minus Y1 whole square. That implies PQ square is equal to PR square plus QR square. PR square is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is what? PR square plus QR square is nothing but z2 minus z1 whole square. Here square root get cancelled. PQ square, what left? Observe, x2 minus x1 whole square, correct? x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, correct? PQ square, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. That implies PQ is nothing but square root of PQ is nothing but what? Square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So PQ from figure, observe, PQ means distance between 2 points in space. Correct? Observe carefully. Observe the diagram. PQ is nothing but what? PQ is nothing but distance between 2 points in space. Agar a formula, the formula is distance between 2 points in space is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is very important derivation. It may ask in 5 marks for annual examination. Distance between 2 points in space is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So what is the difference between distance between 2 points in plane and distance between 2 points in space? Distance between 2 points in plane, only 2 axes. So we left out this one, x2 minus x1 whole square plus y2 minus y1 whole square. Whereas distance between 2 points in space means 3 axes. So x2 minus x1 whole square, square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is very, very important derivation for annual examination. Understand? Okay. If you, after knowing the formula, we solve some problems, distance between 2 points in space. So exercise, find the distance between the following pairs of points. All point 2 exercise, that is, I think the first problem. The points are 2, 3, 5 and 4, 3, 1. The first problem, 2, 3, 5, 4, 3, 1. So first point, 2, 3, 5 I treated as x1, y1, z1. Okay, so that implies x1 is equal to 2, correct? y1 is equal to 3, z1 is equal to 5. Next point, 4, 3, 1, that I treated as x2, y2, z2. That implies x2 is equal to 4, y2 is equal to 3, z2 is equal to 1. This is first step. So we know that distance between 2 points PQ in space is given by x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Correct? Just now we derive the formula distance between what? 2 points in space. Square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Firstly we find x2 minus x1. x2 is what here? 4. 4 minus x1 is what? 2. 4 minus 2 is how much? 2. y2 minus y1. y2 is what? 3. y1 is what? 3. 3 minus 3, 0. z2 minus z1. z1 is what? 1. z2 is what? 1. z1 is what? 5. 1 minus 5 is minus 4. That implies distance between 2 points that I represent PQ. PQ is equal to square root of x2 minus x1 whole square, that is 2 square plus, correct? y2 minus y1 whole square, that is 0 square plus z2 minus z1 whole square, that is minus 4 whole square. Calculate very fast. 2 square is how much? 2 square is 4. 0 square is 0. Minus 4 square is 16. So that is equal to square root of 16 plus 4 is 20. So third simplification also you know in previous classes. So square root of 20, that I written as 4 into 5 to root 5. So distance between these 2 points is given by PQ is given by to root 5. Understand the calculation? Distance between 2 points PQ is given by to root 5. We solve one more problem of same type. The next problem is second problem, minus 3 comma 7 comma 2 and 2 comma 4 comma minus 1. So same method. So the first point I treated as P. Is equal to x1, y1, z1. That implies x1 is equal to minus 3, y1 is equal to 7, z1 is equal to 2. Correct? Second point I treated as q. Q of 2, 4, minus 1, that is that x2, y2, z2. So that implies x2 is equal to what? 2, y2 is equal to 4, z2 is equal to minus 1. You know that distance between 2 points in space is given by x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Correct? Distance between 2 points in space is given by x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Firstly, we find one by one. x2 minus x1. x2 is what? 2 minus. x1 is what? Minus 3. Minus into minus plus 3. 2 plus 3 is how much? 5. y2 minus y1. y2 is what? 4. y1 is what? 7. 4 minus 7 is how much? Minus 3. z2 minus z1. z2 is what? Minus 1. z1 is what? 2. Minus 1 minus 2 is how much? Minus 3. Correct? Substitute all these values here. That implies PQ, distance between 2 points, PQ is equal to square root of x2 minus x1 whole square, 5 square, plus y2 minus y1 whole square, minus 3 whole square, plus z2 minus z1 whole square, minus 3 whole square. Calculate. Tell me how much? 5 square is what? 25. 3 square minus 3 square, it is 9. Due to square, it is plus. Minus 3 square, 9. 25 plus 9 is how much? 25 plus 9. Correct? 25 plus 9 is how much? 34. 34 plus 3. I think it is 43. Correct? 25 plus 9, 34. 34 plus 9, it is 43. So that implies distance between these 2 points is given by square root of 43. I think you are clearly understand. Distance between these 2 points is given by square root of 43. We solve one more problem of same type. Same type question. Find the distance between these 2 points. Next problem. Minus 1, 3, minus 4 and 1, minus 3, 4. Same method. The first point I treated as P. 3 minus 4, that I won't call it as x1, y1, z1. Next point I treat as q, 1 minus 3, 4, that I treat as x2, y2, z2. That implies x1 is minus 1, y1 is 3, z1 is minus 4, correct? x2 is 1, y2 it is minus 3, z2 it is 4. So x2 minus x1, 1 minus of minus plus 1 it is 2, correct? y2 minus y1, minus 3 it is minus 6, z2 minus z1, 4 minus of minus plus 4 it is 8. Correct? All these values. We know the formula. Distance between 2 points in space. Distance between 2 points in space is given by x2 minus x1 whole square plus what? y2 minus y1 whole square plus z2 minus z1 whole square. Distance between 2 points in space is given by x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. That is square root of x2 minus x1 2 square plus y2 minus y1 minus 6 whole square plus z2 minus z1 8 square. Calculate. 2 square is how much? 4. 6 square is how much? 36. 8 square is how much? 64. Correct? 36 plus 4, 40. How much? 36 plus 4, 40. 40 plus 64. Or not? Square root of 104. The distance between these 2 points is given by square root of 104. Clear? Clear understand? We solve one more problem of same type. Find the distance between the following points. The points are -3, -1, 6 and 2, -4, -7. Same method. First point we treated as P. -3, -1, 6 is nothing but x1, y1, z1. Second point Q, 2, -4, -7 that we treated as x2, y2, z2. That implies x1 is equal to -3, y1 is equal to -1, z1 is equal to 6. x2 is equal to 2, y2 is equal to -4, z2 is equal to -7. Calculate x2 minus x1. 2 minus of -3 plus 3, it becomes 5. y2 minus y1. -4 minus of minus plus 1. So -4 plus 1 is -3. z2 minus z1. -7 minus 6 is how much? -13. -7 minus 6 -13. So we know the formula. The distance between 2 points. The distance between 2 points is given by x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Correct? Substitute all those values. Square root of x2 minus x1 5 square plus y2 minus y1 minus 3 whole square plus z2 minus z1 minus 13 whole square. Calculate. 5 square is how much? 25. 9, 169. Correct? 25, 9, 169. Calculate and find out the answer. Calculate very fast. 169 plus 9 is how much? 169 plus 9. 169 plus 9 is how much? 170. 178. Correct? 169 plus 9, 178. 178, 25. 178, 25. Calculate. 178 plus 25. Do not. I think it is correct. 203. Correct? 203. The distance between these 2 points is given by 2 square root of what? 203. Is it clear? So we solve next type of problems regarding the same concept, distance between 2 points. So what do you have? Second type of problem. Show that the points, very important concept, you already know this one also. The points -2, 3, 5. 1, 2, 3 and 7, 0, -1 are collinear or collinear. Show that these 3 points, minus 2, 3, 5, 1, 2, 3, 7, 0, minus 1 are what? Collinear. So you already know in 10th class how to prove collinear by using distance between 2 points. The same concept we follow. So what we do here, the first point we treated as A, okay, A of minus 2, 3, 5. Second point we treated as B, B of 1, 2, 3. And third point we treated as C, C of 7, 0, minus 1. Firstly, what we do here, we find the distance between A to B, the distance between B to C, and the distance between A to C. One by one we find. So directly we solve. We already solves problems how to find distance between A, B, B, C and C, and AB, distance between A, B. Already we know how to solve the problems. AB, 1 minus of minus plus 2 whole square plus 2 minus 3 whole square plus 3 minus 5 whole square. Correct? x2 minus x1, y2 minus y1, z2 minus z1. We already discussed how to solve distance between 2 points. 1 minus of minus plus 2 whole square, 2 minus 3 whole square, 3 minus 5 whole square. That is square root of 1 plus 2, 3 square plus 2 minus 3 minus 1 square plus 3 minus 5 minus 2 square. Correct? So square root of 3 square is how much? 9 plus 1 square is 1 plus 2 square is 4. So 9 plus 4, 13, 13 plus 1, 14. Distance from A to B is square root of 14. Correct? Similarly, we find distance from B to C. Directly I calculate because we already discussed how to solve distance between 2 points. Distance between B to C, 7 minus 1 whole square. Correct? x2 minus x1 whole square plus y2 minus y1 whole square, 0 minus 2 whole square plus z2 minus z1 whole square, minus 1 minus 3 whole square. And that is equal to square root of 7 minus 1 is how much? 6 square plus minus 0 minus 2 is how much? Minus 2 square. Minus 1 minus 3 is how much? Minus 4 square. 6 square is how much? 36 plus 2 square is how much? 4. 4 square is how much? 16. 36 plus 4 is how much? 40. 40 plus 16 is how much? 36 plus 4, 40, 40 plus 16, 56. Correct? 56 are written as 4 into 50, 4 into 14. 14 into 4 is how much? 56. So that I can written as 2 root 14. Distance between B to C. Distance between B to C is nothing but 2 root 14. Next, lastly, we find distance between A and C. Correct? Distance between A and C. AC, square root of 7 minus of minus plus 2 whole square, 0 minus 3 whole square plus minus 1 minus 5 whole square. Correct? Minus 1 minus 5 whole square. So calculate 7 plus 2, 9 square plus minus 3 whole square plus minus 6 whole square. 9 square is how much? 81. 3 square is how much? 9 plus 36. Calculate 81 plus 9, 90. Correct? 90 plus 36. 90 plus 36, 126. Correct? 81 plus 9 is how much? 90. 90 plus 36. 90 plus 36 is 126. That we written as 9 into 14. 3 root 14. Distance from A to C. Distance from A to C is 3 root 14. Observe the problem carefully. So AB is root 14. Correct? This is what? AB. AB is, once again I written here because the conclusion is very important. Distance from A to B, square root of 14. Distance from B to C, 2 into square root of 14. Distance from A to C, 3 into square root of 14. Distance from A to C, 3 into square root of 14. So what he asked, prove that these 3 points are what? Collinear. So to prove collinear by the concept of distance between 2 points, firstly we observe which distance is largest. Correct? To prove collinear, first we observe which distance is largest. Here, among these 3 values, the distance from A to C is the largest. Correct? If suppose this value is equal to sum of other 2 values, what are those? If I calculate AB plus BC, root 14 plus 2 root 14. These 2 are like surds, so that it is nothing but 3 root 14. Suppose this value is equal to sum of other 2 values. Yes, no doubt. That implies AB plus BC is equal to what? AC. If this condition satisfies, largest value is equal to sum of other 2 values. Correct na? Largest value. First we observe among these 3 values which one is largest. Correct? If this value is equal to sum of other 2 values, largest value is equal to sum of other 2 values. If this condition satisfies, that implies given 3 points A, B and C are collinear. Correct? The given 3 points A, B, C are collinear. Here AB plus BC is nothing but AC. Correct? AB plus BC is nothing but AC. Hence, A, B and C are collinear. This is very important concept. For to prove collinear, first we find 3 distances. Distance from A to B, distance from B to C and distance from A to C. Among 3 distances, we observe which value is highest. So that value is equal to sum of other 2 values. That value is equal to sum of other 2 values. If that condition satisfies, we say that given 3 points are collinear. Here AC is 3 root 14, that is highest value. It is equal to sum of AB plus BC. Correct? Sum of AB plus BC. Hence, A, B and C are collinear. Understand? We solve one more problem. Next problem. Show that 0, 7, minus 10. First point. 1, 6, minus 6. And 4, 9, minus 6 are the vertices of an isosceles triangle. This also you already know in 10th class. are the vertices of an what? Isosceles triangle. Okay. So same method. So what we solved in the previous problem. Firstly, we take the point A of 0, 7, minus 10. B of 1, 6, minus 6, and C of 4, 9, minus 6. We calculate AB, distance from A to B, distance from B to C, and distance from A to C. First I calculate AB. x2 minus x1, 1 minus 0 whole square, plus y2 minus y1, 6 minus 7 whole square, plus minus 6 minus of minus plus 10 whole square. Correct? So that is square root of 1 minus 0 is how much? 1 square. 6 minus 7. 6 minus 7 is how much? Minus 1 square. Plus minus 6 plus 4. Sorry, plus 10 is how much? 4 square. That is square root of 1 plus 16. Correct? Is how much? Square root of 18. Distance from A to B is nothing but square root of 18. Similarly, we find distance from B to C. Distance from B to C. 4 minus 1 whole square. 4 minus 1 whole square plus 9 minus 6 whole square plus minus 6 minus of minus plus 6 whole square. Correct? Minus 6 minus of minus plus 6 whole square. That is square root of 4 minus 1 is how much? 3 square plus 6 minus 9 minus 6 is how much? 3 square. It is 0. 3 square is how much? 9. 3 square is how much? 9. So it is 9 plus 9 root 18. You already observe the result. These two results. Distance from A to B. Distance from A to B is also root 18. Distance from B to C. Distance from B to C is also root 18. So similarly we find distance from A to C. I think this is no need, but also we find A to C. 4 minus 0 whole square plus 9 minus 7 whole square plus minus 6 minus of minus plus 10 whole square. 4 minus 0, 9 minus 7, minus 6 minus of minus plus 10 whole square. Calculate this one also. 4 square plus 9 minus 7 is how much? 2 square plus 4 square. 16 plus 4 plus 16. 20. 16 plus 4 is how much? 20. 20 plus 16. 36. Observe these three values. Observe these three values. So what he asked? He asked, show that given 3 points are what? Isosceles triangle. Isosceles triangle, what do you know this one? Isosceles triangle means, a triangle means it contains 3 sides. For isosceles triangle, if any 2 sides are equal, that means AB is equal to AC, or AB is equal to BC, or AC is equal to BC, among 3 sides, any 2 sides are equal, then that triangle we call it as what? Isosceles triangle. Correct? Na? So here, among 3 values, AB, BC and AC, among 3 values, if any 2 values are equal, any 2 values are equal among these 3 values, if any 2 values are equal, here what? AB is equal to BC is equal to what? Root 18. Among these 3 values, any 2 values, AB is equal to BC is equal to what? Root 18. So if this condition satisfies, then that implies the given points A, B and C are the vertices of an isosceles triangle are the vertices of an isosceles triangle. Among three values, once again I say that among three values, if any two values are equal, any two, either AB is equal to BC or AB is equal to AC or BC is equal to AC, any two values are equal, then the given 3 points are the vertices of an isosceles triangle. Understand? Okay, we solve one more type of problem. Show that, next problem, show that 0, 7, 10 minus 1, 6, 6 and minus 4, 9, 6 are the vertices of a right angled triangle. This one also you know, are the vertices of a right angled triangle. Okay, we will see this one. The first point I treated as A of 0, 7, 10. Second point B of minus 1, 6, 6 and third point C minus 4, 9, 6. Same method, we calculate distance from A to B, distance from B to C and distance from A to C. Firstly, we calculate distance from A to B, AB, square root of, observe AB, minus 1 minus 0 whole square plus 6 minus 7 whole square plus 6 minus 10 whole square, correct? 6 minus 10 whole square, that is square root of, minus 1 minus 0 is how much? Minus 1 square plus minus 1 square plus 6 minus 10 is how much? Minus 4 whole square. So 1 square is 1 plus 16 is how much? AB is equal to square root of 18. So I calculate AB square. AB square root get cancelled. It is 18. Correct now? AB is equal to square root of 18. AB square is 18. Then we find distance from B to C. Distance from B to C. So minus 4 minus of minus plus 1 whole square plus 9 minus 6 whole square plus 6 minus 6 whole square. 6 minus 6 whole square. So calculate minus 4 plus 1 minus 3 whole square plus 9 minus 6 3 square. 3 square is how much? 9. 3 square is 9. 9 plus 9, that is 18. BC is equal to 18. BC square 18. BC square is 18. Then we find distance from what? A to C. Distance from A to C. That I written here. A to C. Minus 4 minus 0 whole square plus 9 minus 7 whole square. 9 minus 7 whole square plus 6 minus 10 whole square. Correct? 6 minus 10 whole square. That 6 minus 10 minus 4 minus 0 is how much? Minus 4 whole square plus 9 minus 7 is how much? 2 square plus minus 4 whole square. 2 square minus 4 whole square. That is equal to minus 4 is how much? 16 plus 4 plus 16. How much? Square root of 36. Correct? 16 plus 4, 20. 20 plus 16 is how much? 36. Square root of the AC square. 36. AC square is 36. So we find distance from A to B, distance from B to C, and distance from A to C. What we have to prove? To prove that given 3 points or vertices of a right angle triangle, okay now, or the vertices of a right angle triangle, firstly we observe among these 3 values, which value is largest? AB square, BC square and AC square. Observe among these 3 values, AB square, BC square, AC square. Among these 3 values, which value is largest? Which value is largest? AC square. AC square is equal to 36, correct? So this value is equal to sum of other 2 values. Calculate sum of other 2 values. AB square plus BC square. AB square is how much? 18 plus 18, that is equal to 36. That implies, I written here, that implies what? AC square is nothing but AB square plus BC square, correct? AC square is nothing but what? AB square plus BC square. This is nothing but what? The Pythagoras property of a right angle triangle. Correct now? The Pythagoras property of a right angle triangle. In a right angle triangle, hypotenuse square. Hypotenuse is nothing but a largest value, largest distance. Hypotenuse square is equal to sum of the squares of other 2 sides. Hypotenuse square is equal to sum of the squares of other 2 sides. If this condition satisfies, that implies A, B and C are the vertices of an right angled triangle. Right angled triangle. So if Pythagoras property satisfies, then these 3 points or these 3 vertices are the vertices of a right angled triangle. One more point you observe here. Observe AB square. AB square is also 18. Yes, now. So observe carefully. AB square is 18, BC square is 18, AC square is 18. Observe these 2 values. Among 3 distances, 2 distances are similar. Last problem. 2 distances are similar. So AB is equal to BC is equal to what? Root 18. Then what it indicates? A, B, C are the vertices of an what? Isosceles triangle. Correct na? A, B, C are the vertices of isosceles triangle. Hence, by combining these 2 results, A, B and C are the vertices of an isosceles right angled triangle. Correct? A, B, C are the vertices of an what? Isosceles right angled triangle. Very important. To prove, once again I recall all the previous problems. To prove collinear, we find 3 values: A to B, B to C and A to C. Among these 3 values, we observe which value is highest. Correct now? Which value is highest? If that is equal to sum of other 2 values, if this condition satisfies, these 3 points are the collinear. This is first one. For isosceles triangle, so first we find 3 values: A, B, B, C and AC. Among these 3 values, if any 2 values are equal, then A, B, C are the vertices of isosceles triangle. Third point, third concept, First we find AB, BC and AC. AB square also, BC square, AC square. So we observe which value is highest. Suppose AB square is highest. If AB square is equal to BC square plus AC square, it means it satisfies Pythagoras property. It satisfies Pythagoras property. Then we say that given 3 points are the vertices of a right angled triangle. Okay, thank you. We will explain the next class.